in a composition function form, it's not really, you don't know what f is, you don't know what g is. So we're going to be able to do all these derivatives with just like f of x, g of x, h of x, okay? And stuff like that. So here I can definitely see that I have an inside and an outside. So there's the inside. So as I do my chain rule, I'm going to take the derivative of the outside. So what's the derivative of f? F prime. So I take the derivative of the outside, leave the inside all alone. Okay, leave it the same. Then I'm going to multiply by the derivative of the inside, 2x minus 1. And be careful that you have these parentheses, because if you just put dot 2x minus 1, the only thing you multiply this guy by is what? 2x. So just be careful that you have those parentheses. Okay? So then it says, find the slope of the line tangent at x equals 1. So now we're just going to find p prime of 1. Oh, thank you, negative 1. So that would be f prime of negative 1 squared is 1 minus a negative 1 would be 2 times, plug in negative 1, negative 2 minus 1, negative 3. And that's all we can do for now. And then maybe they'll have a chart that shows us what f prime of 2 is, and then we can plug it in. But for now, that's all we know. Okay, on the next one. Yeah. Got this out. Okay. So on this next one, I have an inside, and then inside of that, I have this inside, right? So what do we have today? Wait, come on. So let's see. First, I'm going to do the yellow part. So just do that part. Okay. So as I take my derivative, that's going to become derivative of the outside. So I bring my 3 down, leave the inside alone. So what's that? And now it's raised to the second. So that yellow part stayed the same. Agreed? Now I got to take the derivative of that inside. So when I do the derivative of this inside, I have an inside of that as well. So I'm going to do the derivative of g, leave that inside alone. Now times the derivative of that inside, which is 2x. Yeah. I don't know. However you want to try to simplify it. Okay. And you could actually see this guy as g squared right here of x squared. And how do we know that doesn't mean a derivative? Okay, so derivatives, I could have like g prime, or g double prime. If I wanted to put a 2 to show a derivative, it would have to be in parentheses. Okay? So this is how I know it's not a derivative, because it's not in parentheses. Alright? That's how I know it means b squared. I'm okay if we don't do all of that. Okay. You guys know what that is? Yeah, what does all this guy mean? What does this guy mean? No! It means you're gonna add one, you keep adding, and then you divide by the total of what you have. It's the average. I want it to be greater than the average. Okay, so now we're at 2 5.
Bad math jokes.
Love it.
How I know.
Algorithm.
How do you think our dad feels?
Okay, so Chris, refocus. Now we are on implicit differentiation. So this is the last part of chapter 2 before our test on Thursday. So we're going to see the difference in explicit and implicit. We're going to talk about what we need to remember, okay? But here, what we're going to do is we must be able to derive implicitly. I will derive. Some of you guys are like, I don't know what that means yet. That's okay. We're going to talk about it. Recorded and will be on YouTube today. Okay, so implicit versus explicit. These guys right here, when you already have y solved for, or you have this g of x equals, and everything here is in terms of x, okay? So you have the one variable, like y or g of x, which would mean y, and everything else is in terms of x. Those have been explicit functions that we have been doing. So those have been explicit. Now we're actually going to see a little bit different where it's going to be implicit. So implicit here is basically when I have x and y all mix matched and I can't just solve for y. Now let's look at this first one. Could I solve for y? Sure. I could get that to explicit and life would be happy. Okay? So, great. Can I solve for y on this guy? Let's see, y squared would be 16 minus x squared, but when I go to solve for y now, how many functions am I going to get? 2. Because when I go to do that, I'm going to have plus or minus that square root. So this does not make me happy. Okay? That's not going to be one that we want to do explicitly. We would need to leave it and work through there. Okay? Implicitly. On this guy, could I even solve for y and get it in terms of x?
No.
No, I mean, I could move over an x squared, I could try to factor out a y, but I'm still going to have y on the other side. So again, I cannot get that guy explicitly. I'm going to have to do these two explicitly. So these guys are going to, implicitly, are going to be implicit. Okay? We're going to have to leave them. That's what we're going to see how to do today. Okay, so when we can't just solve for y in terms of x, and we use this implicit differentiation, we are going to do just like we would, but when we differentiate y, we have to put dy dx. That's the only really new thing. When I take the to say what I took it with respect to. And later we're going to see when we start taking y's and x's with respect to some other variable. Okay? So if let's just kind of go back, and I said y equals that 2x plus 3. Let's say I had something like this. If I took the derivative of y now, we would say that's dy dx already. So it's kind of like saying, well, what's the derivative of y if I was just looking at the power rule? It would be 1. Agreed? And then I'd say, well, now we're going to do dy dx. And then this guy would have been 2. And you didn't know you were doing it yet, but the whole time you were saying you took the derivative of x with respect to x, which, hey, just becomes 1. So you were going and saying that dy dx equaled 2, and life was good. Agreed? Okay, what if I then now put something like y squared equals x squared plus 9? Now, we're still going to be taking this derivative of y squared. Do your power rule. 2y. And the only little difference is we're going to throw in a dy dx. Equals, this guy becomes 2x dx dx, which I don't have to write, because that's just going to be 1. So all of that stuff is exactly like we had been doing. So the only new thing is when I take the derivative of y, I need to write dy dx. That kind of makes sense. All right. Okay, so our steps. Differentiate both sides with respect to x. Put all dy dx terms on the same side. Factor out the dy dx, solve for dy dx. Okay? So that's basically how we're going to be doing these steps. So just a little note. It's not always going to be with respect to x. Okay? It's not always going to be with respect to x. Sometimes you're going to take it with respect to t or some other variable. So we're going to have to pay attention to what it's with respect to. Okay? So here, we're going to take this guy and we're going to derive. Now, could I solve for y here? I could have solved for y and done explicit. And let's see how that's different, or the same, basically, as implicit. So let's go ahead and do the implicit, the new one. So I'm going to take the derivative with the power rule of x, which becomes 1/3 x to the negative 2/3 dx dx. Do I have to write that? No. If you want to, go for it. Plus, yes. Right, because it's not 1, it's not like 5/5. Yeah. Okay, so let's do this one now. So that's going to be 1/3 y to the negative 2/3. And now I took the derivative of y, so I have to put dy dx. Equals, the derivative of 19 is 0. So now we want to go solve for dy dx. So subtract over, divide, all that fun stuff. So I'm going to first subtract that guy over. by 3. Still okay? No, we're going to get that whole thing on the other side. Okay? So y to the negative 2/3 is kind of the same. It's the same as this guy. Agreed? So what can I multiply both sides by? Y to the positive 2/3. I still have that negative. And you could rewrite that as negative y to the 2/3 over x to the 2/3. And that's what my dy dx would equal. Questions on any of those steps? Now, again, note, we could have actually solved for y. And if we can, it makes life a little bit easier, okay? But most times when it says this, we can't. So let's just solve for y first. That would be what, 19 x to the 1/3. And then what can I raise everything to? 3, right? So y would equal 19 minus x to the 1/3 all to the 3rd. And then I could have went and actually got my derivative and everything here. So then I could have just said dy dx equals, break my 3 down, times 2, times the derivative of the inside, which is going to be negative 1/3 x to the negative 2/3. Okay? And I'm really confused because how is this equal to what we got in our answer over there? How are those two guys equal? Because they should be, because they're both the same dy dx. They started with the same equation. Basically, what did they just go do? If I solved for y now and plugged it in there, would I end up getting the exact same thing? Yeah. And here I can see the 3's will cancel, right? I can bring my negative 2/3 for the x part down, and I'm going to have the exact same thing. Okay? Okay, let's look at this one. Can I even solve for y? No. So that's not even going to be an option. What do I notice here? What is this called? Product rule. What about here? Product rule. Okay? So we have the product rule going on. Okay, so my thoughts as I'm kind of starting this, if I'm going to just make my little thought guide, is I'm going to have product rule. I'm going to have dy dx when deriving the y. And, believe it or not, one of the biggest mistakes, the derivative of a constant is 0. Okay? So I'm going to remember that. That's one of those big, big mistakes that people make. So these would be my big thoughts of where students mess up when they're doing this. They forget to do a product rule, they forget to do dy dx, and they forget to put the derivative of a constant as zero. So those are my thoughts of not to forget as I go to start this problem. Okay, you ready? So let's first do this product rule. So I'm going to take my first times the derivative of the second. So derivative of y becomes 1. I took the derivative of y, so I need to write dy dx. So there's my first times the derivative of the second. Plus my second times the derivative of the first, which is 2x. Since I'm deriving with respect to x, it's just dx over dx. Don't need to write it. Okay? Okay, so there's that first part. Now let's do this product rule. So I have the first times the derivative of the second. Check the derivative of an x, so that's now dx dx. We're fine. Plus the second times the derivative of the first. I took the derivative of a y, so now I need to write dy dx equals, so there's that product rule. We're good there. What's the derivative of a constant? 0. So that's the other big rule. Okay? So get the products, get those dy dx's, and know that the derivative of a number is 0. Now we got to try to solve for dy dx. So we got to leave this and this guy. We're going to leave those on the left. Get everything else to the right of the equal sign. Go. That's just some algebra. It's kind of like solving for a variable. So leave those guys alone. Bring everything else over to the right. See if you're okay with that one. I'm leaving the stuff that has a dy dx because I'm trying to solve for dy dx. You will have one like this on every test from henceforth. Just so you know. Okay? You will have a question like this on every test you have from now until you get an MVC. You know how to do it. Okay, so now I'm going to factor out my dy dx. Oops. And this is the most steps I will ever take from now on. I mean, I'll shortcut this guy, okay? Like, I'll go from this line right here to the final answer. So now, dy dx I can divide through, and there's my final answer. What do you think? Not too bad? Just keep that little thought blurb in your head when you do these guys, okay? Okay, let's look at the next one. Can I solve for y? Okay, so now we're going to do this one implicitly. You want to try it? together. Okay. So this first one, I see a product. And then on the second one, I see a product on the inside of the cosine, which tells me I'm going to have a chain with a product. Okay, so the product's on the inside. So this product's on the inside of a chain. Can you kind of see that? All right, you ready? You ready? Yeah! All right, four. So we're going to do our first. So first we're going to go do this guy. Okay, we'll do that product first. So the first times the derivative of the second. Derivative of 1 goes to 0. Derivative of cotan goes to C, so it definitely is going to go to a negative. Negative what? Cosecant squared of y, right? Times the derivative of the inside. So what's the derivative of y? 1. We took the derivative of y, dy dx. Questions? That part. Okay, so now we have it equaling that. So I'm going to take the derivative of the outside, leave the inside alone. So what's the derivative of cosine? Negative sine, leave the inside alone, times the derivative of that inside now. The derivative of the inside is where I have the product. So I'm going to do the first, times the derivative of the second. Derivative of y becomes 1. Took the derivative of y, so I write dy dx plus the second times the derivative of the first, but I took the derivative of x, which is dx. Don't need to write it. So there we go. Now I got to solve for dy dx. So let's go ahead, let's distribute. Okay, let's get this cleaned up a little bit. So negative x cosecant squared y times my dy dx, right, that whole thing, equals negative x sine of xy times dy dx minus y sine of xy. See if you're okay with that. Now these are the terms that have dy dx. So I need to get those on one side and everything else on the other side. So I'm going to go ahead and just move my dy dx's to the left, because this has already something else with it to the right. So factor out your dy dx. and then divide. The last thing I could see them doing, this doesn't be a multiple choice question, okay? The last thing I could see them doing is saying, oh, let's go make that positive, that negative, that positive, and flip-flop the order down here, just to simplify the signs, okay? So instead of having two negatives, they'd only have one negative. And that would just be a matching on the multiple choice that you guys could do. So multiply by negative 1. Okay, see how your table mates are doing. See if there's any big questions so far. How are we doing? Okay. I want you guys to try this one with your table mates now. With your squad. With your buddies. Oh. What are you doing? Extra credit for today. go to 0.
Oh,
You can plug it in at the end or now or whenever you want. You can plug it in at any point in time. You guys all solve for d by dx? If you solve for d by dx, I have what that is.
Good morning, Parkhill. Monday, September 12th, the red day. Congratulations, Rick Weatherby, your Parkhill today. Nominated Paul. Positivity is excellent in the classroom. Today's birthdays include Edith Belkin, Tyler Jenkins, Riley Brockman, Christina Gerster, Adeline Star, Cole Hartrup, Yvonne Barnes, Amani Marshall, Kristen Walden, Nikki Baker, Breaker, Alexander Gillum, Phil Harris, Governor Staff. It is homecoming week, and the rest of his birthday today is Olympic Monument Day. Tomorrow is Happy Tourist Day. Wednesday is Squad Day, so looking like your partner. Throwback Thursday, and Friday's Cooking Day.